Okay, so let's talk about a volume of rotation using our disk method. And what we're interested in is finding the volume of a shape bounded by the curve y equals the cube root of x minus 1, the lines x equals 0, y equals 0, and y equals 1, and rotated about the y-axis. So we're going to have to go through one by one here, and let's work what this thing would look like out. All right, so we've got, here's x equals 1. We know that x equals 1, our curve y equals the cube root of x looks like this. It passes through the x-axis there. Uh, it looks kind of like a cubic curve on its side. So it would pass to the point 2, 1 right here. It would pass to the point negative 1, 0 right here, and it would look kind of like this. Sort of exaggerating the curve a bit, but you get the idea. Okay, so there's my curve. Y is equal to my cube root of x minus 1. All right, so now I want to find the area that's bounded by that curve. The line x equals 0, well, the line x equals 0 is the y-axis. The line y equals 0, and the line y equals 0 is the x-axis. And the line y equals 1. So the line y equals 1, plot that right here. Here it is, y equals 1. Okay, so we're looking for the area that's enclosed right here. Let me shade this in a little bit. That's right here. There it is. Okay, so we're looking for this volume, and it's rotated about the y-axis. So the way that we're going to have to do this by the disk method is we're going to have to set up a disk, and a disk in this case is found by setting it up according to the y-axis right here. So we're going to have to set up a little rectangle right over here along the y-axis. Let me straighten up that disk a little bit. There we go. That's much nicer. Okay, so we're gonna take this particular disk right here, and let me shade that in a little bit so I can kind of differentiate it from the rest of it. And we need to make that a dy disk right here that we're going to just. So that means that our function has to be rewritten in terms of x as a function of y. All right, so let's see, what are we going to do? Well, in the y direction, dy is going to go to 0. That's our lower bound, to 1. So that's good. So we've got some bounds on our integral right here, 0 to 1, for our volume. So our volume is going to be equal to pi times some function of y squared dy. All right. So what is our function of y? Well, this is where we're going to have to do a little bit of a creative rewriting. We've got y is equal to the cube root of the quantity x minus 1. Let's rewrite that. That's going to become y cubed is equal to x minus 1 if we raise both sides to the third power. Then we add 1, so we're going to get y cubed plus 1 is equal to x. So that's the function that we're going to have to substitute in right here. Here is f of y. Right? F of y is y cubed plus 1. Okay, very often we have to find our function by rewriting it so that it's in terms of y if it's not given that way already. So we're going to take our volume to be the integral of pi, or pi times the integral from 0 to 1 of y cubed plus 1 quantity squared dy. So, well, we're going to have to rewrite this by expanding. Well, expanded y cubed plus 1 times y cubed plus 1 would be y to the 6th plus 2y to the 3rd plus 1. And so we take our integral of each of the terms one by one. We're going to have a volume equal to pi times the quantity, 1/7 y to the 7th plus 1/2 y to the 4th plus y evaluated from 0 to 1. Well, 0 and 1 happen to be some awfully convenient numbers for us because that means we're going to get pi times the quantity 1/7 times 1 to the 7th plus 1/2 times 1 to the 4th plus 1 all minus 0. All right, so let's see what that's going to work out to be right here. That is to say 2 plus 7 plus 14 over the LCD of 14. And rewriting that a bit, right? 2 plus 7 is 9, plus 14 is 23. So our volume is going to be 23 pi over 14 units cubed. And that would be where we would get our volume of revolution of this particular shape, which seems a little weird kind of shape, but you can imagine that this shape revolved around our y-axis, looks maybe a little bit like a urn or a dish of some sort, right? Well, it's hard for me to draw this, but you get the idea. Anyways, that's how we would go about this.